So on the screen here, we've highlighted 5 key enabling technologies that have got us and the product to where we are today. The first being digital state-of-the-art electronics. So moving away from having large electronics housing on the side of the valve to a slim, very modular PCB approach that sits directly within the housing of the valve, as you can see on point 1 of the diagram. Secondly, we've moved to an approach that harnesses electrical closed-loop position control using magnetic Hall effect sensors. So most direct drives today use large, bulky, linear positions transducers with relatively average resolution and performance, whereas we're able to harness the benefits of magnetic Hall effect sensors that are both very, very tiny, weighing only a couple of grams, at the same time as being so small, the resolution that we can achieve and the control accuracy that we can achieve is far greater. The third key enabling technology is using high-performance brushless 3-phase DC motors as opposed to a solenoid drive, which is the standard today. These motors enable us to achieve a high amount of torque for the same given electrical input, which enables us to control the valve both at high pressures when the flow forces on the spool are great and maintain accurate control at high frequencies. The fourth point, which is linked to point 1, is our advanced control algorithms and firmware. These algorithms enable our products to keep up with the highest demands in terms of step input speeds and frequencies to minimize overshoots and maintain very accurate, repeatable and precise control. Fifth and finally, which is something Alessandro alluded to earlier, is our use of metal 3D printing within the valve. Within servo valves, we have a patent here at Domin which protects us from using additive manufacturing within a servo valve design. And you can see just by looking at the geometry of the valve itself, we're able to use simulation tools like CFD to determine the optimum flow galleries to minimize pressure drops and optimize flow rates. And then thanks to the flexibility the manufacturing technology gives us, we can actually create a design and manufacture a design that is as close as possible to the optimal results using the technology that's currently available. Additionally, something you might be able to notice is the wall thicknesses are very thin within the manifold. So again, taking advantage of another simulation tool, FEA, finite element analysis, we can identify what's the minimum amount of material that we need given the operating conditions and pressures that the valve is going to have to withstand, and then only print the material that has functional properties, so withstanding stresses, and as a result, there is very, very little wasted material.